Hello, welcome to the University of South Florida's Master of Science in Electrical Engineering for Professionals Capstone project for summer 2014. This will be a comparative review of 3C SiC-based semiconductor components versus silicon-based components as used in power electronics. Project team members include Daniel Simons, AJ Patel, Anand Rampadarath. Dr. Steven Sidal will be our coordinating advisor. Dr. Farakides and Dr. Hoff will be our technical advisors. Silicon semiconductors have been the industry standard due to their reliability, efficiency, and ease of fabrication. Many advances have been made over the past 2 decades, one of which is silicon carbide semiconductors for high field and high power device applications for harsh environments and certain bio, nano, and MEMS applications. This project will focus on the cubic form of SiC, commonly known as 3C SiC. We will conduct a literature search to identify mainstream uses for 3C SiC devices. We'll utilize the published characteristics, including material analysis and calculation of key performance factors, to compare 3C SiC and silicon side by side. We'll identify the benefits from the properties exhibited by 3C SiC, create a cubic form of silicon carbide device model for use in PSpice, employ that device model within a circuit design, and then simulate a power supply using the cubic form of silicon components compared to the performance with silicon-based components. At the end of the day, we want to perform circuit simulations within the created 3C SiC device models and analyze the model's performance characteristics and compare it with the silicon-based model. Utilize the simulation model to show at a minimum comparable performance of the 3C SiC to SiC-based system, and provide a detailed analysis that shows the outcomes of the literature search, device modeling design, and simulation results that highlight the merits of 3C SiC. Benefits of 3C SiC components include smaller size, higher operating temperatures, faster switching times, larger breakdown voltage, and reduced cooling requirements. Now we'll take a look at some of the basic properties of 3C SiC compared to silicon. This table shows electrical and material properties side by side of silicon and 3C SiC. Of note, the band gap is greater for 3C SiC. The breakdown electric field strength is also greater. The saturation drift velocity is greater. And the thermal conductivity is also greater, which makes it a superior structure for the use in power electronics. Okay, here we depict the structure of silicon and a silicon carbide power Schottky diode and show the forward current voltage IV characteristics. On the left side, we have the structure with the cathode, anode, substrate, regions in between, etc. The circuit equivalent model, as well as the current calculations. On the right, the IV characteristics. The top, we have the silicon diode, and the bottom is the silicon carbide diode. Notice the increase in current characteristics with the power silicon carbide diode at the same given temperature, 25 degrees Celsius. Here we see the specific on resistance versus breakdown voltage for silicon and silicon carbide in an ideal situation. Notice for the ideal silicon carbide, the specific on resistance is very small compared to the ideal silicon situation at a given breakdown voltage. This is the power supply we'll be using for our simulation purposes to compare the silicon-based semiconductors versus the 3C SiC semiconductors. It's a 100-watt rectifier. We'll perform simulations using the silicon diodes, then replace those diodes with 3C SiC equivalents. We'll compare performance using PSpice simulations, and then conduct a complete survey as part of the project. Project schedule looks as follows, with minor deviations and fluctuations as required. The following slides will present information about our team members. I'm Dan Simons. I received my Bachelor of Science in Electrical Engineering with honors from the University of South Florida in 2007, after which I was commissioned in the United States Navy. I'm currently serving my 16th year of active duty.
I'm Ajay Patel. I have a bachelor's degree with honors in physics and microcomputer electronics from the University of London in the UK. I currently work for General Electric Healthcare as a systems engineer, primarily responsible for the implementation and design of radiology imaging software and systems.
I am Anand Rampadarat, and I am currently a lecturer at the Anton de Kam University of Suriname, located in my home country, Suriname, South America.